Hello, welcome to today's class on Understanding Geography with Diagrams. See, today we'll basically be talking about your tropical cyclones. So, basically, what do we mean by a tropical cyclone? As you can see, as we have defined in this, that a tropical cyclone is the form of a weather disturbance occurring in the tropical region in between 5 to 30 degree north and south, which is in the bracket, accompanied by the rotating wind, thunder, and precipitation. Please make it add. Next, the tropical cyclone basically, see, this definition is basically what I got, means what I had analyzed from the total definition. I read it out and I totally analyzed this thing. There is nothing to be copied in it. Next, see, the tropical cyclone basically we say is of four types. What are this? One is your tropical disturbance. Now, see, this tropical disturbance is otherwise called as your easterly trade winds. Sorry, it's called as the easterly waves. Sorry, not the easterly trade winds. Extremely sorry for that. They're called your easterly waves because they move from east to west. See, they are popularly known as the easterly waves. This disturbances basically what they do is that they originate near the boundary of the trade winds with the doldrum. It means simply look at this. This is your doldrum. This is your northeast, southeast trade winds, and it is in this boundary regions that they are confined. Remember that the doldrum shifts, that is, they shift between your Tropic of Cancer to Tropic of Capricorn. It is basically, remember that uh, your tropical cyclones do not occur in equator. It's basically in these regions that they are occurring and not in the equator. Next, they move westward at a slow, generally characterized by the clear weather with the cumulus cloud followed by precipitation due to the movement of the cumulonimbus. Sorry, I think that I've made the mistake in the spelling. It's nimbus cloud. Occasionally, due to this intense stability, they emerge as hurricane. Now, this thing you need to remember: the tropical cyclone that if they intensify, they will convert into hurricane. What are the basic characteristics? First of all, we learned is that they are the easterly waves. As they are moving from east to west, and these disturbances originate near the boundary of the trade wind. Two. These are the two most important things, and that they are accompanied by the sea. Be it the tropical disturbance, be it the depression, cumulonimbus cloud is something that is common. Next, we'll move to cumulonimbus cloud. Now, cumulonimbus cloud, what we call it? We call it a small size low pressure encircled with more than one closed isobar. How do we say? This is the small sized low pressure and it has more than closed isobars. These are nothing but your isobars. See, when the, as I had said earlier, if the isobars are placed close, then what will happen? It will simply lead to the higher wind velocity. Hence, these are the small size low pressure centers encircled with more than one isobars with variable wind velocity with average speed ranging from 40 to 60 km per hour. Simple. What is it? Small sized low pressure center enclosed enclosed your isobars with a wind speed of 40 to 60 km. Now this occur most frequently again in the ITCC and are rare in the zone of the trade winds, as we could understand. Next, one of the important features is that this is the most important feature, that this depression normally fails to attain the size of a storm and die out of the weak disturbance. Now with this you can clearly mark out the difference between your tropical depression and your tropical disturbance. If I say tropical disturbance, then it occasionally intensifies instability and may turn it into a means they may emerge as a hurricane, but such is not the condition of a tropical depression. Next, tropical storm. Again, tropical storm is tropical depression versus tropical storm. Tropical storm is nothing but a larger low pressure area with enclosed isobars. Simple. Tropical depression, smaller low pressure area with enclosed isobar. Tropical storm, larger. See, the low pressure center and it's basically a larger, I would say. Uh, comparatively larger. This is over here, let's write. It's a larger low pressure center encircled by a closely placed isobar with wind velocities ranging from 63 to 118 km per hour. Next, they are the most common in Bay of Bengal, Arabian Sea, Caribbean Sea, in the vicinity of Philippines, etc. This is the most another thing is that they are associated with heavy precipitation and storm surges in the coastal areas. See, now you can say that, sir, why did you say storm surge over here in the coastal area? See, look at the speed. The storm surge, one of the main causes of the storm surge is nothing but your wind speed. Now, what is the storm surge? Storm, see, this is your land and this is your ocean. Storm surge simply means that whenever there is a high speed wind, the waves would attain a higher height, as a result of which this will result to your coastal erosion, flooding, etc. etc. Next we come over here to tropical cyclone. Now tropical cyclone is nothing but a warm vortex circulatory wind system of the tropical origin with closed and circular isobar. They sustain the maximum limit speed of 119 km with torrential rain. Now within this, please try and draw this chart. It says that cyclonic storm, the speed basically range from your 50 to 60, severe cyclonic storm 90 to 120, and very severe cyclonic storm 120 to 160, and super cyclone it's 200 plus. This is important, please add this. Next, now within this, what you can basically see is that it is nothing but the distribution of your tropical cyclone, where the tropical cyclones are distributed, as well as what we call them. See, basically we know that we call them typhoon where in Philippines, we call them bilibilis in Australia. This is called typhoon in Japan, as it has already been written, and it is hurricane over here and cyclone over here. See, in this diagram itself, what you're saying is that you're not just describing the name, but you also, with this red zones, what you're showing is that you're basically showing their distribution. Now this is very important, showing their distribution. Now in one diagram you're giving them the different names and distribution. This makes your diagram more effective, hence try to add this diagram. Next, origin of the tropical cyclone. The formation of the tropical cyclone depends upon the fulfillment of the following. First, there must be your continuous supply of the large amount of moist air. Now moist air is absolutely necessary. Now where it is going to get the moist air, it's going to get the moist air origin majorly from your western side of the ocean, from the marginal water bodies. See, they say that mostly that the tropical cyclone originate in the western side of the ocean and not in the eastern side of the ocean. I can technically say you that this is somewhat incorrect, given the condition that in the Indian Ocean, remember that the cyclone not just originates in the Bay of Bengal, but it also originates over the Arabian Sea, and that is the thing that we need to remember. But in general, what happens is that in the eastern side of the ocean, which has significant presence of the cold current, what happens is that the temperature obviously reduces, hence it does not lead to the formation of a cyclone, hence it's majorly formed on the western side. Now if you say that Bay of Bengal versus the Arabian Sea, you see that more number of cyclones are on the Bay of Bengal when compared to Arabian Sea. Similarly, anywhere in any continent, you basically see that the side which has the warm current has generally more number of cyclones than the side with the cold current. Next, now this is basically the fact for understanding. See, fact for understanding means you do not need to write this fact. It will unnecessarily take your time, but this is nothing but your basic understanding. You can go through it. In case doubt, ask me. Next, where to ask me, you know it. Next, storm. See, another is the strong Coriolis force. See, basically what happens is that, as you know, the cyclone is missing in the equator, because in the equator the Coriolis force is 0. Now why the Coriolis force is 0 in the equator? One reason that I can give you is that, first of all, at the 0 degree latitude, see, first of all, the Coriolis force is directly proportional to the sign of latitude. 0 degree latitude means 0 Coriolis force. Number 2, is that the land and the water distribution is such uniform that there is hardly any temperature difference, or the pressure gradient is very minimum. Hence, it's also one of the reasons, but mostly the 0 degree latitude is the main reason. Now, see. Now, why do we require it? Because of the anticyclonic motion of the tropical cyclone is because of your Coriolis force. Next, upper level divergence. It means that there must be an anticyclonic circulation. What is anticyclonic circulation? It says that over here, if there is a cyclonic circulation, above there must be anticyclonic circulation. Means if there is a low pressure, there must be a high pressure over here. See, I'll make this understand to you while I will be discussing the entire diagram. Next is the minimum vertical wind shear. What is this minimum vertical wind shear? It means that see that the wind speed at the troposphere and the upper troposphere must be minimum, and that too they must be in the same direction. If they are not, means see, if there the wind shear is what? Wind shear is nothing but your difference between the wind speeds at different altitude. If the wind speed is high, means supposing you say that over here that we have a normal wind speed, and above we are having a very high wind speed. Let's say there is a prevailing jet stream at the top. Then what will happen basically is that this will weaken the cyclonic formation, and hence this is the very reason that during the monsoon, that is during the June to August, we rarely find any cyclones, and this is the very reason. Fact for understanding. Next, we have the existence of a mild disturbance. Now, what is this mild tropical disturbance? Now, mild tropical disturbance is your nothing but your this. Number one is your tropical storm, tropical disturbance. A minor tropical disturbance means nothing but your tropical storm and the tropical disturbance, which is a necessity for the existence of the cyclone. Next, now the structure of the tropical cyclone. Please understand the structure of the tropical cyclone. I'll basically use the diagram. See, first and foremost, there is your eye. What is this eye? Eye is nothing but your low pressure, and eye has this is nothing but your eye wall, as it has been shown. These are your eye walls. Now this within, now as we had known that there must be a high pressure over here, and this is nothing but your high pressure zone, and this is also called your blocking anticyclone. Next, we have over here is the rain zone. Rain zone where there is cloud, precipitation. Now basically understand this blocking anticyclone, or this is the high pressure that remains over here. It is nothing but your, what happens is that it basically is the main source of your wind. It means that the wind descends. Once the wind descends, what happens is that they get adiabatically heated and they rise, and this rising will lead to what? This rising of the heat will lead to the cloud formation and hence precipitation in the rain zone. I hope you understood the link between your low pressure over here and the blocking anticyclone over here. Let's come to the structure of the cyclone. Yes, one more thing is that as you move away from your eye walls, what will happen? The precipitation will increase or decrease. Write it in the comment section. Next, there is the eye of the cyclone. The eye, the most important, see, it says that the most important structural characteristics of a tropical cyclone is known as the eye of the cyclone. It's basically the calm wind, clear skies, elliptical circular. It simply means that rainless, windless zone. Next is the eye of the eye wall. Eye wall is nothing but the region which is surrounding this regions which is surrounding your eye is called as the eye wall. Next is that the spiral shaped band. See, the spiral shaped band is what we basically when we see this tropical cyclone from your from the overview, that is from the satellite, you'd basically see that they are completely circular round. This is circular round is nothing but your, it's called your the spiral shaped band. Next is your annular zone. See, annular zone, basically you can see it over here. This is your annular zone, means it is the outer boundary of the tropical cyclone. What it is exactly doing, see, this region is basically hot and humid. Next to the annular zone, we have the outer convective zone. And next to the outer convective zone, we have the trade wind cumulus zone. What is this outer convective zone? Zone is surrounding the annular zone. And then we have the trade wind cumulus zone, constitutes of the outermost fringe of the cyclone. Next. See, one thing about the effect of the tropical cyclone. See, the tropical cyclone are put under the meteorological disaster category. They result in the great loss of life and property, mainly in the coastal areas. The damage caused by tropical cyclone is mainly associated with three actions: storm surge, destructive wind, and inland freshwater flooding. This is one of the important statements. I need you to write this important. Remember this statement and write it whenever it comes with respect to the effect. That is the storm surge, destructive wind, and the inland freshwater flooding that is responsible for that enhances the damage of the tropical cyclone. Again, see, this is the tropical cyclone. There is nothing more in it. Basically, I hope the tropical cyclone is clear with you. Now, if you want to write a question, basically what you can write, I have a question for you. That is the tropical cyclone, its type and its effect. Simple. Tropical cyclone, its type and its effect. Done. Next. And do answer me the question that I had asked. I hope you remember where I have asked the question. Thank you.